In this video, I'll be going over the CFA practice and review that we're doing today with logarithms and exponential functions. So here in this first problem, Jane got a new job, housing market can be modeled by this function here, which if you notice is a log, where V represents the current value after T or time in years. So if we want to know which equation would represent the value, notice how we're solving for V. Well, notice how V is here inside and the log is by itself. So now the inverse, because we're trying to do inverse operation, so the inverse of the log is a exponential. So here we have our base, which is 1.15 raised to the t power is equal to 12,000 times V. Now notice we are solving for V, so now we need to divide inverse operation by 12,000. And here that's why the answer is C. Now here in question number 2, we're solving for X and we have a natural log function. And so here that means we need to get our natural log here by itself. Well, if it's being multiplied by 5, then we need to divide both sides by 5. Now I've got the natural log of X is equal to 7. Now we can do the inverse of natural log, which is E. So now when inverse operations cancel out, you get X is equal to E to the 7th power. Then you can put that in the calculator and E to the 7th power is approximately 1096.63. Now here in number 3, we're simplifying, but we can use our property because notice how we have two logs where the bases are the same, and when adding, we don't add. That means we are multiplying the two values when we condense. So this is log base 5 of 12 times 3. Because again, our log property, this is our product property. When the bases are the same, when adding, we're going to multiply. So this is the same as log base 5 of 36. Then of course, notice how we can rewrite this as change of base formula. So this is log of 36 divided by log of 5, which is approximately 2.23. Now in number 4, we're finding the inverse. So here I'm going to go ahead and switch my X and Y value. And notice we have an exponential, so we will end up with a log. But we first have to get it by itself. Treat it like a two-step, so I'm going to subtract 1 first from both sides. X minus 1 is equal to 3 times my exponential. So because we're still multiplying by 3, divide both sides by 3. So we've got X minus 1 over 3, which is equal to now our exponential, which is by itself because Y plus 2 is altogether in the exponent. Now we can write it as a log. So this is log base 4 of X minus 1 over 3, which is equal to the exponent Y plus 2. So notice how here to solving for Y, we now need to subtract 2 from both sides. And here the inverse operation is log base 4 of X minus 1 over 3 minus 2. And so now here in number 5, we are solving for X with our log function. Well, here, if we have our log, which is by itself, we're going to go ahead to solve for X, convert it to its inverse, because we're doing inverse operations, which is an exponential. Notice how here we have a common log, so the base not 3, the base is 10. So here I've got a base 10 to the 2nd power, which is equal to 3x plus 1. And so now here we can solve for X. Notice how we have 10 squared. Well, 10 squared is 100, which is equal to 3x plus 1. Now you're just solving a two-step. So now here I can subtract 1. Now I've got 99 is equal to 3x, and then divide both sides by 3, and that's why x is equal to 33. Now in number 6, we're finding the inverse of the function. Remember, f of x is the same as y. So here, let's go ahead and switch our x and y. So x is equal to the natural log of y minus 5 plus 7. Well, first we got to get natural log by itself. So subtract 7 from both sides. X minus 7 is equal to the natural log of y minus 5. Now we can use e, which is our inverse to natural log, our function here. So e to the x minus 7 is equal to, canceling out inverse, and bring down y minus 5. But notice now here, in order to solve for y, we now need to add 5 to both sides. That's why here the answer is A, because you have e to the x minus 7, then plus 5. In question number 7, we are solving our equation. We have an exponential, but first get it by itself. So we're going to subtract 1 first from both sides. 6 to the 2x minus 1 is equal to 36. Now there are different ways that we can solve this equation. I'm going to go ahead now to bring my exponent down, write this as a log. So I've got log base 6 of 36, which is equal to 2x minus 1. So now notice here we have our change of base. So that is log of 36 divided by log of 6. Here, that's how you end up with 2, which is equal to 2x minus 1. Now we can go through and solve for x. I'm going to add 1 to both sides. Now I've got 3 is equal to 2x and divide by 2. That's why the answer here is C. In number 3, we're going to condense and write these 3 logs as one log. But before we do that, always make sure if you have any coefficients to write as your exponent. So notice how 2 here, our coefficient, can be rewritten as log of x squared. Then bring down minus log of 7. Now 3 can be written as an exponent. But because they're both x and y being raised to the third power, I'm going to go ahead and rewrite this as log of x cubed times y cubed. And so now we can start writing this as one log. So here I've got log of, remember subtraction represents division, but here x squared is positive. So I'm going to put x squared in my numerator. But then minus log 7, so we're dividing 7, as well as x cubed times y cubed. But now notice we're not done because we can simplify what's inside. Notice how we have 2 x's in the numerator, but 3 x's in the denominator, which means both x's are gone in the numerator and we're left with 1 x. So this can be rewritten as, when there's nothing left, we now have 1 over 7x times y to the third. And so now in number 9, we're going to expand. But first we need to simplify what's inside of the parentheses. So notice how here you have 4 over 12, which is 1/3, or 3 in the denominator. Then x's cancel out, and z's also cancel out. So notice how this was 1/3, and really you're just left with y squared in the numerator. So really, after simplifying, because everything else canceled out, we are just left with this that we need to expand. So I've got the natural log of y squared, but because 3 is being divided, minus natural log of 3. Then don't forget, whenever you have an exponent, to write that as your coefficient. So this is 2 times the natural log of y minus the natural log of 3. And so now here in number 10, we are solving for x, but a little different here. We do have an exponential. We just have more variables here, but we're still going to follow the same process. Here I need to get my exponential by itself, so I'm going to divide both sides by s because that's what's being multiplied. I'm going to bring down r divided by s, which is equal to 3 to the 2t times x. Now we can write this as a log. So this is log base 3 of r divided by s, which is equal to your exponent, 2 times t times x. Now notice we are solving for x, but it's being multiplied by 2t. So we need to divide both sides of the equation by 2t. And that's why here, solving for x, you end up with b. Then in question 11, same thing. We're solving for x, but We're now given a log, so we're going to go the other direction. Now the log is now by itself, so we can write this as an exponential. My base is 2r, so 2r being raised to the t power. Remember, your equation is always equal to the exponent, which is equal to s times x plus 3. And again, we're solving for x. Now I'm going to follow my 2 steps, so I'm going to subtract 3 here. So now I've got 2 to the r raised to the t, 2r raised to the t power minus 3 is equal to s times x. We are still multiplying x by s, so now divide by s. And here, x is equal to this new function here. And so now in question number 12, we're looking to determine which of these statements are true. Well, first off, with this exponential, we need to get it by itself. So I'm going to divide both sides by 2. I've got 5 to the x is equal to 25. So now, well, 5 to the what power is 25? Well, 2. So that means x is equal to 2 because 5 squared is 25. So x is equal to 2, not 5. Now, technically, I could rewrite my exponential as a log. So this is log base 5 of 25, which is equal to your exponent, which here is x. So that's why here the third statement is true, not the fifth one. Then notice we can rewrite this as the change of base, where we divide our two logs here. So I have log of 25 divided by log of 5. That's why the last statement is also true and not the second statement. So these are the 3 statements that are true. In question 13, we're talking about the population of rabbits. We have our rate here, 7.8% or 0.078, and we're using this exponential model. So we are using E function, but now setting up a little differently. P is still representing the final amount of rabbits after T years. P sub 0 is representing the start, the initial. So here, we currently have 13 rabbits, so that's your initial. How many rabbits will there be on the property in 8 years? So that's your T, your time. So we are looking for the number of rabbits. So P is equal to 13 times E, raise that to the power, which is 2 times R times T. So 2 times our rate, which is 0.078, times T, which is 6. As I just put T there, my fault, which is 8. So now we can just straightforward put this in the calculator, and the approximate population of rabbits is going to be 45. So 45 rabbits. So now part B is asking us to solve for T. So I'm going to rewrite this. P is equal to P sub 0, then our E function raised to the 2 times R times T power. So now here, first, our E function is not by itself. It's being multiplied by P sub 0. So we're going to divide by P sub 0. So now here I'm going to bring down P divided by P sub 0, which is equal to our E function being raised to 2 times rate times time power. Now that E is by itself, what is the inverse of E? Natural log. So we're going to take natural log of both sides. Now notice we keep that together. So this is the natural log of P divided by P sub 0, which is equal to inverse operations cancel out. And now I can bring down my exponent, 2 times rate times time. We're solving for T, and notice how it's still being multiplied by 2R. So now divide both sides by 2R. And T is equal to this function here.